So hi everyone, it is second lecture of chapter 4, that is moving charges and magnetism. In yesterday's class we have discussed about what is magnetic field. The space or the field around a current carrying conductor or a magnet in which magnetic force can be experienced is known as a magnetic field. It is represented by the letter B, its SI unit is Tesla, right? How we can determine what are the different rules or laws by which we can determine the direction of the magnetic field? Generally, we use right hand thumb rule and Fleming's left hand rule to find the direction of the magnetic field or the force on a moving charge placed in a uniform magnetic field, right? And we also discussed yesterday about the force on a moving charge in magnetic field. When a moving charge which moves with v velocity enters in a uniform magnetic field B, then what happens? This is uniform magnetic field. A charged particle enters parallel. So there are several cases. First one case is if the charged particle enters there with a parallelly, okay? Theta is equals to 0 degree, right? So this is the uniform magnetic field. This is the charge which enters in the uniform magnetic field. So the force exerted by this magnetic field on the charge, that force is directly proportional to the magnitude of the charge. That force is directly proportional to the velocity vector with which it is moving. This F is directly proportional to the magnetic field in which it is placed, and this force is directly proportional to the sine theta, okay, by which angle it enters into the uniform magnetic field. When we combine these four equations, we have F is equals to Q VB sine theta. That means Q V vector cross B vector, right? Q VB sine theta. From here we can also define a magnetic field. That magnetic field is equals to force per unit charge which is moving with v velocity vector and enters perpendicularly into the uniform magnetic field. So this is a force. F is equals to Q VB sine theta. Force on a moving charge which is moving with v velocity and enters in the uniform magnetic field. तो नाम में ही फॉर्मूला छुपा हुआ है that Q charge जो v velocity के साथ मूव कर रहा है enters in the uniform magnetic field, F force act on it. इलेक्ट्रिक फील्ड में जो फोर्स थी that is QE. मैग्नेटिक फील्ड में एक मूविंग चार्ज में जो फोर्स होगी वो Q VB sin theta because it moves with the v velocity, right? So there are different cases. First one case is when the charge particle enters in uniform magnetic field parallel to the uniform magnetic field B. ठीक है, यूनिफॉर्म मैग्नेटिक फील्ड बी में वो पैरेलली एंटर कर रहा है विद थीटा 0 डिग्री. सो व्हाट इज द फोर्स ऑन दैट चार्ज पार्टिकल? क्यू वी बी साइन थीटा, राइट? तो थीटा इज इक्वल्स टू 0 डिग्री. एज वी नो साइन एट 0 डिग्री इज इक्वल्स टू 0. सो नो फोर्स एक्ट ऑन इट क्योंकि उस पर कोई फोर्स नहीं लग रही है. सो इट मूव्स एज इट इज इन द स्ट्रेट लाइन क्योंकि वो एज इट इज मूव कर रहा है. सो वर्क डन इज ऑल्सो 0. व्हाट इज द फॉर्मूला फॉर वर्क डन? What is the formula for work done? It is a dot product of force and displacement. So work done is equals to F dot S, right? If the force is 0, then work done is also 0. So no work is done on the moving charge which enters in a magnetic field, right? So work done 0 होगा इस केस में. Next, if the charge enters anti-parallel to the uniform magnetic field, यानी कि थीटा इज इक्वल्स टू 180 डिग्री पे अगर वो सपोज एंटर करता है तो थीटा इज इक्वल्स टू 180 डिग्री. व्हाट इज द फोर्स? F इज इक्वल्स टू Q VB sin थीटा. थीटा इज इक्वल्स टू 180 डिग्री एंड साइन एट 180 डिग्री इज इक्वल्स टू 0. दैट्स व्हाई फोर्स इज इक्वल्स टू 0. इसका मतलब अगर वो एंटी पैरेलल आ रहा था यूनिफॉर्म मैग्नेटिक फील्ड के तो वो एज इट इज स्ट्रेट लाइन में मूव करेगा विदाउट एक्टिंग एनी फोर्स. उस पर कोई फोर्स नहीं लगेगी. हियर ऑल्सो वर्क डन इज इक्वल्स टू 0. ना वर्क डन हुआ था जब वो 0 डिग्री पे एंटर कर रहा था मूविंग चार्ज, ना ही वो 180 डिग्री पे एंटर कर रहा है तो वर्क डन हुआ है, राइट? सो नो वर्क इज डन. नेक्स्ट वी हैव द थर्ड केस. थर्ड केस, द चार्ज enters in a uniform magnetic field with एंगल 90 डिग्री और परपेंडिकुलरली, ठीक है, perpendicularly, ठीक है. And the charged particles enters in the uniform magnetic field perpendicularly, right? This is uniform magnetic field. The charged particle enters perpendicularly, right? Like this is how it enters perpendicularly. So what happens? What is the force? Theta is equals to 90 degree, right? It enters perpendicularly. So what is the force which act on it? What is the formula? It's QVB sin theta. That means F is equals to QVB sin 90 degree, and sin 90 degree is equals to sin 90 is equals to 1, right? sin 90 पे कितना होता है? वैल्यू 1 होती है. So maximum force exert on it, that is QVB, right? So the question may be asked कि when will the force becomes maximum या when will the force becomes minimum? तो minimum force उस charged particle पे कितनी होगी? When it moves parallel or anti-parallel in a uniform magnetic field. यानी कि force 0 तब होगी जब वो थीटा 0 डिग्री या 180 डिग्री पे एंटर करेगा यूनिफॉर्म मैग्नेटिक फील्ड में, और मैक्सिमम फोर्स एक्सर्ट कब होगी? when it enters perpendicularly into the uniform magnetic field. जैसे मैग्नेटिक फील्ड इस तरीके से है, ठीक है, this is a uniform magnetic field and the charged particle enter perpendicularly, right? Theta is equals to 90 degree. So maximum force exert on that charged particle. So maximum force exert on it. This maximum magnetic force provide that charged particle necessary centripetal force. That's why it starts moving in a circular path. ठीक है? So this maximum magnetic force acts on the moving charged particle and it provide necessary centripetal force to that charged particle. ठीक है, that means F is equals to maximum force जो act हो रही है QVB, equation number 1, it provide necessary centripetal force that is mv square by r. ठीक है, तो centripetal force is a resultant force which comes due to the resultant of the other forces, and its formula is mv square by r, and it acts towards the center across the radius. ठीक है, so this force provides the charged particle necessary centripetal force due to which it moves in a circular path. ठीक है, मैक्सिमम फोर्स उस पे लगेगी हर एक पॉइंट पे, जिसकी वजह से हर एक पॉइंट पे इट चेंजेस इट्स डायरेक्शन, एट एवरी पॉइंट इट चेंजेस इट्स डायरेक्शन एंड मूव्स इन अ सर्कुलर पाथ, राइट? सपोज अब ये यहाँ पे है, मैक्सिमम फोर्स इस पे लगी, जैसे ये एंटर किया, हाउ इट मूव्स, ठीक है, इट एंटर्स, so the direction is like this, so it moves this, then direction like this, direction like this, direction like this. So how it moves? It moves in a circular path. ठीक है, so this is the force. So these are two forces act on it. So at every point the direction, the tangential direction या tangential velocity will be there. ठीक है, which points the, yeah, which indicates the direction of the motion of that charged particle, right? Why it follow the circular path? Because towards the center centripetal force act, ठीक है, and that centripetal force came from the maximum magnetic force जो मैग्नेटिक फील्ड प्रोवाइड कर रहा है टू द चार्ज पार्टिकल, राइट? जैसे उसमें मैग्नेटिक फोर्स लगेगी, इट बेंड इनवर्ड्स, ठीक है, वहां से सेंट्रीपिटल फोर्स उसको मिलेगी, दैट्स व्हाई इट मूव इन अ सर्कुलर पाथ, वो सर्कुलर पाथ फॉलो करेगा, राइट? सो व्हाट हैपन, what you have to remember, you have to apply the some rules or the phenomena which are used in the uniform circular motion. So what is uniform circular motion? यहाँ से उस पे maximum force लग रही है, so it follow the uniform circular motion. तो uniform circular motion में क्या होता है? If we talk about UCM, uniform circular motion, तो uniform circular motion का मतलब हो गया it has uniform speed, ठीक है? उस चार्ज पार्टिकल की जो स्पीड रहती है वो यूनिफॉर्म रहती है. यूनिफॉर्म स्पीड दैट मीन्स स्पीड रिमेन्स कांस्टेंट, राइट? जिस भी स्पीड के साथ, यानी कि वेलोसिटी का जो मैग्नीट्यूड है वो सेम है. इफ इट मूव्स विद 5 मीटर पर सेकंड कंटिन्यूअसली, इट स्टार्ट्स मूविंग विद 5 मीटर पर सेकंड स्पीड. नेक्स्ट, इफ वी टॉक अबाउट द वेलोसिटी, so velocity is remains constant or it keep changing, because yesterday also we have discussed कि there are 3 ways जिससे velocity में change हो सकता है, ठीक है? या तो उसकी डायरेक्शन में चेंज हो रहा हो, या उसकी मैग्नीट्यूड में चेंज हो रहा हो, या दोनों चीजों में साइमल्टेनियसली चेंज हो रहा हो. सो इन दिस केस ऑफ यूनिफॉर्म सर्कुलर मोशन देयर इज चेंज इन द डायरेक्शन. हर एक पॉइंट पे डायरेक्शन जो है वो डिफरेंट है, ठीक है? सो डायरेक्शन डिफरेंट होने की वजह से वी से दैट वेलोसिटी विल बी वेरिएबल. इसका मैग्नीट्यूड सेम रहेगा, बट क्योंकि इसकी डायरेक्शन में चेंज हो रहा है, दैट्स व्हाई वेलोसिटी इज वेरिएबल. कांस्टेंट कब होती है वेलोसिटी? जब पार्टिकल एक ही सेम डायरेक्शन में मूव कर रहा हो विद द कांस्टेंट मैग्नीट्यूड. एक सेम डायरेक्शन में सपोज एक पार्टिकल मूव कर रहा है विद 5 मीटर पर सेकेंड, ना डायरेक्शन चेंज हो रही ना मैग्नीट्यूड चेंज हो रहा है, तब हम कहेंगे वेलोसिटी कांस्टेंट है. बट इन दिस केस ऑफ यूनिफॉर्म सर्कुलर मोशन, direction keep on changing at every point, but magnitude remains same. That's why it is a variable quantity in this. तो यूनिफॉर्म सर्कुलर मोशन में वेलोसिटी क्या रहेगी? वेरिएबल रहेगी ड्यू टू द चेंज इन द डायरेक्शन एट एवरी पॉइंट. नाउ अब यहां से क्वेश्चन ये पूछा जाता है कि व्हाट अबाउट द काइनेटिक एनर्जी और द मोमेंटम इन केस ऑफ यूनिफॉर्म सर्कुलर मोशन व्हेन मैक्सिमम फोर्स एक्सर्ट ऑन इट. आपसे डायरेक्टली पूछ लिया जाता है, इनडायरेक्टली भी पूछ लिया जाता है कि जब मैग्नेटिक फोर्स मैक्सिमम होगी, देन विच आर द फिजिकल क्वांटिटी दैट रिमेन्स कांस्टेंट और विच आर द फिजिकल क्वांटिटी दैट कीप ऑन चेंजिंग. सो व्हाट अबाउट द काइनेटिक एनर्जी? Kinetic energy, it remains constant. Why it remains constant? Because the magnitude of the speed or velocity remains constant throughout the motion. क्योंकि magnitude constant है. And what is the formula? It's half mv square. Because kinetic energy is a scalar quantity. So हम यहाँ पे क्या लेते हैं? Velocity का सिर्फ magnitude ही consider करते हैं. So that because the magnitude of the velocity is constant, that's why the kinetic energy remains constant. ठीक है? So during the circular motion of the charged particle in the uniform magnetic field, kinetic energy remains constant. If we talk about linear momentum, या if we talk about the momentum, ठीक है? Momentum, that means mv, but momentum is a vector quantity. तो हम velocity की दोनों ही चीजें इसमें consider करते हैं, magnitude as well as direction. क्योंकि डायरेक्शन वेरिएबल है, डायरेक्शन की वजह से वेलोसिटी वेरिएबल है, दैट्स व्हाई मोमेंटम चेंजेस, यानी कि मोमेंटम भी क्या होगा? वेरिएबल होगा, ठीक है? एंड व्हाट अबाउट द वर्क डन? अभी हमने बात की थी, ठीक है, कि वर्क डन क्या होता है? व्हाट इज द फॉर्मूला फॉर वर्क डन? इट्स एफ डॉट एस डॉट प्रोडक्ट ऑफ फोर्स एंड द डिस्प्लेसमेंट. क्योंकि अगर चार्ज पार्टिकल 0 डिग्री या 180 डिग्री पे एंटर कर रहा है यूनिफॉर्म मैग्नेटिक फील्ड में, तो फोर्स जीरो हो जाती है, दैट्स वाई वर्क डन इज जीरो। और अगर 90 डिग्री पे एंटर कर रहा है तो थीटा 90 डिग्री हो जाता है, इट्स कॉस 90 डिग्री, राइट, ठीक है ना, कॉस 90 डिग्री। बिकॉज इन केस ऑफ यूनिफॉर्म सर्कुलर मोशन यहाँ पे जो फोर्स और डिस्प्लेसमेंट है दे हैव 90 डिग्री एंगल बिटवीन देम। तो yesterday also we have discussed कि जितनी भी सर्कुलर मोशन वाली चीजें होती हैं, the objects which follow the circular motion they have zero work done because the angle between the force and the displacement is 90 degree, and we have work done is equals to fs cos theta, ठीक है, fs cos theta, तो theta is equals to 90 degree, that's why work done is equals to 0. Question may be asked in assertion reason or in the MCQs that is the magnetic field do any work on the moving charges? So they don't do work. Work done is equals to 0 when the charged particle moves in a uniform magnetic field, right? So these are some physical quantities which some of them remains constant and some are variable in case of uniform circular motion, right? So this is a case where maximum force exerted on it when the charged particle enters perpendicular to the uniform magnetic field and it follow the uniform circular motion or the circular path. Here we can equate these two. These are the forces. So by equating first and second, by equating first and second equation, what we got? QVB is equals to mv square over r. And v will be cancelled out with the v component, ठीक है, but we have r radius which the charged particle follow to move in the uniform circular motion. So r is equals to mv over qb. By this radius the charged particles moves in the uniform magnetic field. We can also find the velocity or the kinetic energy or the different physical quantities like momentum from here, ठीक है, the time period and the frequency. So how we can find? This is r is equals to mv over qb, ठीक है, r is equals to mv over qb. So this is a radius, ठीक है, this is the radius by which the charged particle follow the circular motion, ठीक है, इस रेडियस के साथ जो है चार्ज पार्टिकल मूव करेगा. सेकेंड वी हैव काइनेटिक एनर्जी. So kinetic energy is the energy possessed by the charged particle while moving in the circular motion. So motion में जो objects होते हैं they have the kinetic energy. So what is the formula for the kinetic energy? It's half mv square. We can also find the velocity from here, ठीक है, v is equals to it's r qb over m, ठीक है, v is equals to r qb over m. This is the expression for the velocity. The charged particle moves with this velocity, with this magnitude in the circular motion, right? This is the expression for velocity. What is the expression for kinetic energy? We put the value of v from this equation number 3 to equation number 4, ठीक है, mark it equation number 4. So put the value of v from equation 3 to equation 4. So what is the expression for kinetic energy? It's half m. By putting V R Q B over m, it's square. By opening the square, we have half. M will be cancelled out with the m. What we have? The expression, it's half R square, Q square and B square. So this is the expression for the kinetic energy, right? Radius, if you have to find the radius, if you have to find the velocity, this is the formula. If you have to find the kinetic energy, this is the formula. Next, momentum. Momentum, linear momentum, formula is, it is represented by P. P is equals to mv. If we have to find the magnitude, so m, what is the expression for velocity? R QB over m. R QB over m. M will be cancelled out with m. So P is equals to RQB, right? Next, if we have to find the angular velocity with which it moves, angular velocity. So how we can find the angular velocity? What is angular velocity? A rate of change of angular displacement, that is omega is equals to theta by t, or omega is equals to 2 pi by t, or omega is equals to 2 pi nu. These are the three formulas for the angular velocity. So from here we can find, firstly we have to find omega. What is the formula we are going to use? There is a relation between linear velocity and the angular velocity. What is that? It's V is equals to R omega. We know V, velocity we have to, and we can easily find omega. Okay. So by using the relation V is equals to R omega, we can easily find omega as V upon R. You can put, it's your own wish, you want to put the value of R or you want to put the value of V over here. If we put the value of R, what is the value of R? Yeah, what is the formula for R? mv over qb. Okay. mv over qb. V over Q. Okay. So V will be cancelled out with V. So what is the formula for omega? QB over M. Okay. QB over M. This is the formula to find the angular velocity. V is equals to R omega. This is a relation between linear velocity and angular velocity. This is linear velocity. V, linear velocity, and this is angular velocity. Right? So we have expression of omega. If we have omega, we can easily find the time period. Okay? Time period of revolution in the circular motion. So what is the expression? We have done three formulas of omega. Omega is equals to theta by t, 2 pi by t, or 2 pi nu. By this formula, we can find omega. Okay? Time period. We have the expression for omega. Now we can find the time period as well as the frequency. So to find the time period, we use the formula omega is equals to 2 pi by t, or t is equals to 2 pi over omega. By putting the value of omega from this formula into this formula. So 2 pi upon it's QB over M. So 2 pi M over QB. This is a expression for time period, right? So what is the expression for time period? T is equals to 2 pi M over QB. This is the time period of revolution in the circular path by the charged particle. Next, similarly, we can find the frequency, the linear frequency. Okay? The linear frequency by which it can revolve in the circular motion. So what is the formula? You can use omega is equals to 2 pi nu, or you also find with the time period. Okay? Time period se find kar sakte hain, it's your own wish. You're going to use this one formula to find the frequency, or the time period and frequency are reciprocal to each other. Okay? Time period and frequency are reciprocal to each other. That means nu is equals to 1 by t. Nu is the frequency, t is the time period of revolution. So this is formula you can use. So nu is equals to reciprocal of time period. Time reciprocal का जो formula है उसको reciprocal कर दें. तो q b over 2 pi m. Right? This is how we can find the frequency of the charged particle while moving in the circular motion. So these are the physical quantities and the formulas of the different physical quantities, and work done is equals to 0 in this case, right? So from here numerical may be asked, and these are the physical quantity which also used in the cyclotron. Okay. So this is how, when the charged particle enters in a uniform magnetic field perpendicularly, that means at theta angle 90 degree, the charged particle enters, then maximum force exerted on it, which provide it necessary centripetal force. That's why it moves in a uniform circular path. Okay, so circular path it follow. The question may be asked,